Hi children and viewers, in this video I am going to explain about resistivity and conductivity. Children, this topic is important for 2 marks and for problems also it is important, and this topic is important for competitive exams also. So that's why you have to watch the video very careful. You have to pay much more attention while you are watching the video. So simply very simple and very easy topic. So children, after watching the video, share your opinion as like, comment, and if you can like my videos, subscribe my channel. So I am going to topic children, resistivity and conductivity. Already we discussed what is the resistance and what is a resistor. What is mean by resistance? The opposition shown by the conductor to the flow of charges. That phenomena is called resistance. The opposition shown to the flow of charges, that should be called resistance of a conductor. The resistance should be depend upon the nature of the material and size of the material and temperature of the surrounding. So here already I explained what it is resistor. Resistor is nothing but the device or the conductor which can shows the property of resistance. That should be called resistor. I already explained that the resistor symbol should be like this. It seems to be like hills, and this is the symbol for resistor. And in some circuit diagrams, here we are getting one more symbol for resistance. So here the value of resistor, for example in circuit we have like this, then there is no change in value of resistance even though the current is passes through it. That means that will stops the constant amount of charge while the current is passing through the resistor. Clear? So generally in circuit we are showing like this, means it is the variable resistor. What is that? Variable resistor. So resistor, what is the difference between resistor and variable resistor? Resistor means if you are finding in the circuit should be like this, that will stop the same amount of charges, or that will opposes the same amount of current or charges while the current is passes through it continuously. But in case of a variable resistor, the value of resistance should be changes with respect to the flow of current and with respect to the surroundings, and in this case the value of resistance should be same. That should be constant. That's why that will stops the same amount of charges while the current is passes through the circuit. This is simply about the resistance, resistor, and what is the difference between a resistor and variable resistor. So children, here next thing is what is resistivity. Children, resistivity definition is important for 2 marks in our IPA examinations. Resistivity, here there is some relation between R and this is the L. L is length of the conductor. What's that? Length of the conductor. R is proportional to L. That means the resistance of the conductor is directly proportional to the length of the conductor. Length of the conductor. This is the first thing. To understand this, I am giving one example for you. Here we have one slab, it is there. This is the slab. Clear children? That should be having length L. And we kept another slab of same type of slab that should be having some length L. Clear children? When we have only one slab, its length is L and its resistance is R. This is the first case. Clear? Now what I am telling, already we are taken two slabs of equal lengths. That means here L plus L, that is what? 2L. 2L is the length. 2L is length. So here when length is double or length is increased, what about the R value? Let us check. So here when they have like this is series combination, when they have series combination, here the potential across the first slab is V1 and here V2, V1 and V2. So here we are applying the V1 is equals to V2 is equals to V. That means the same potential is across the both. Then in this case I am saying now here the total potential is what? In series combination what to take? V is equals to V1 plus V2. That means simply what it is, V effective is equals to V plus V, that is 2V. When we have like this, the potential is nothing but here 2V. And in this case the current passes through the every slab is same. Every slab is same because the current is moving in only one path. Here this is nothing but series combination of slabs. That's why here the potential difference across the two slabs should be different. That's why I am taking here V1 and V2. And what I am telling here, the potential is V1 and V2 and the same amount of current is passed through the same thing is what? The same amount of current is passed through the two slabs. That's why here in this case the value of R is changes. The value of R is changes. That should be taken as R dash. Generally what we know, V is equals to IR. Ohm's law. What is that? V is equals to IR. From that what we write? R is equals to VI. R is equals to VI. So here this is R is what? Resistance. When we have only one slab of length L, then its resistance is R. And that should be written as R is equals to V by I. R is equals to V by I. Clear children? Now in this case we are taking two slabs and there should be placed some side by side. Then length is increased. How much it is? L plus L, 2L. And in this case we are writing now here R dash is equals to, by using the same relation, R dash is equals to V dash by I dash. V dash by I dash. So here V dash is nothing but 2V and I dash is I. Then what do you write? R dash is equals to 2 into V by I. R dash is equals to 2 into V by I. That means what children? R dash is equals to 2 into V by means what? R. Then what do you write children? R dash is equals to 2R. That means what you have to say? When we have only one slab, then length is L, then what do you write? R is equals to V by I. That means value of resistance is what? R. When we can keep them side by side, what do you have to say? When we can keep them side by side, what do you have to say? Length is increases. When length is increases, here resistance also increases. So this is the first relation between children, relation between resistance and length of the conductor. Resistance and length of the conductor. That means here when the value of length of conductor is increases, resistance also increases. That means there is some directly proportional between these two. Directly proportionality between the R and L. So that is this is the one of the best examples children. Children, resistance of the conductor is directly proportional to the length. To prove that, we are taking one example here. Initially we are taken one slab that should be having length L and its resistance is R. Its resistance is R. When we have general definition for resistance is what? R is equals to V by I. That means when we have one slab, its resistance is R. Clear? And now we are taking two slabs, they should be side by side. And like they are in series combination. I clearly explained series combination in case of capacitors. In case of capacitor, one should be joined like this continuously. So that's why here the amount of current passes through the every slab is same and length is double, L plus L is 2L, and for first one potential is what? V1 and here V2. So that's why here both are here taken identical slabs. That's why we can take potential V1 is equals to V2 is equals to V. That's why here the total potential is now here V is equals to V1 plus V2 plus V3 like that. That's why here V1 plus V2 means what? V plus V. That's why here we are taking now R dash is equals to V dash by A dash. That means here in this case 2 is V dash means what? 2V, and I dash means what? I. Again what do you write? R dash is equals to 2 into V by I. V by I means what? R. Then what do you get? R dash is 2R. That means the given equation is right. R is proportional to L. And children, we have another relation between the R and area of cross section of the conductor. Area of cross section of the conductor. So that is, children, R is proportional to 1 by A. That is equation number 2 here, children. Resistance of the conductor is inversely proportional to the area of cross section. Area of cross section of the conductor. The resistance of a conductor is directly proportional to the length of the conductor and inversely proportional to the area of cross section of the conductor. So to understand that, we have one example is there. So generally here now, the same example we are taking now here. This is the one slab of length L and its area of cross section is A. Clear? Length L and area of cross section is A. Then the resistance can be written as R is equals to V by I. R is equals to V by I. So this is the resistance. R is equals to V by I we are taken. Now that same slab should be cut into two equal parts along its length. That means here now slab is divided into two layers like this. Now in this case, what will say? Now here area becomes as A by 2 because divided into two parts. A by 2 is the area of cross section of each one, and this A by 2 also area of cross section of this. So here each one is having some area of cross section is A by 2. Now after that, when this is divided into two parts, now here the amount of current is passing through the two paths. Here when we have only one slab, the current is moving in only one path. When we are taken two slabs and they are in parallel, or they are one by another, then what you have to say, children? The current is passes through the, everything is same here, I by 2. Clear? When we have one slab, the current is here I only because the current is moving in only one path, and the slab is divided into two equal parts along its length, and they should be placed one by another. Then here when it is the slab is cut into two equal parts along its length, then what you have to say? The area of cross section is divided into two equal parts. That means area of cross section of each one is A by 2, and for this also A by 2. And when they are in parallel, here we have only one potential, that is V. Clear? And next thing is, what you have to say? V1 is equals to V2 is equals to V. That is the relation here. And now what I am telling here, the current is passing through two slabs. That's why in two paths. That's why here what you have to say? The amount of current passes through the every slab is I by 2, like I by 2. So now we have to substitute here. R dash is equals to what? V by I. R dash is equals to V dash by I dash. Then here what you have? R dash is equals to V dash means what? V. And I dash means what? I by 2. I by 2. Then here R dash is equals to 2 into V by I. R dash is equals to 2 into V by I. This is the resistance of one slab with respect to the area of cross section A by 2. Then R dash is equals to 2 into V by I. That means what? When it is divided into two equal parts, then the resistance of every slab should be increased or double. Clear? That means when A by 2 is, A by 2 means what? Decrease in the area of cross section. Decrease in the area of cross section. What you observe? R dash value is increase. Like that, how we can write? R dash is equals to, we can write like 2R. Here R dash is equals to 2 into V by I. V by I means what? R. Then R dash is equals to 2 into R. That means when area is reduced to the half, then resistance is doubled. That's why they are in inversely proportional. Clear, children? R is proportional to 1 by A and R both are in inversely proportional. When we have only one slab, area of cross section is A and current is I, then the resistance can be written as R is equals to V by I. When it is divided into two parts, the amount of current is passes through the every slab is I by 2 and I by 2 and area becomes A by 2. Then we are substituting here R dash is equals to V dash by I dash, and R dash is equals to V dash means what? V, and I dash means what? I by 2. Then what we get? R dash is equals to 2 into V by I. Then R dash is equals to what, right? 2R. That means when area is decreased to half, R becomes double. So this is the relation between area of cross section and resistance, children. So here, by using these two relations, now we have to define the resistivity or conductivity. Okay, children? So here, from equation 1 and 2, from equation number 1 and 2, what we have to conclude, children? From 1 and 2, what do you conclude? The resistance of the conductor is directly proportional to the length of the conductor and inversely proportional to the area of cross section of the conductor. So we have two equations are there. From these two equations, from equations 1 and 2, what you have to write? R is proportional to L by A. R is proportional to L by A, and to equate them we have to use one proportionality constant, that is here R is equals to rho into L by A. Here R is equals to rho into L by A. So here rho is the proportionality constant. What is that? Rho is the proportionality constant. It is also known as the resistivity. What's that? Resistivity. So that's why here I am writing again rho is equal, R is equals to rho into L by A. From that what you write? Rho is equals to what you have to write? RA by L. So now this is the expression for resistivity. What's that? Expression for resistivity. Rho is equals to RA by L. And now here what do you have? How we can write the units of this resistivity? Rho is equals to RA by L. From that here I am going to try to write the units of that rho. Here what is R? R is resistance. Unit is what? Ohm. And what is A? Area of cross section. What is the unit? Meter square. And what is L? Length. How it can be measured? In terms of meters. Now here I am going to write the units. Here rho is equals to, how we can write? R means what? Ohm. We are writing ohm. Area is meter square by length L is what? Meter. Then what do you write? Rho is equals to ohm meter square, square cancel. What do you get? Ohm meter. So here now units of resistivity what? Ohm meter. Simply it can be defined as the it can be represented as like ohm meter. What's that? Ohm meter is the unit for resistivity. Got, children? Rho is equals to RA by L. In that form equation I am going to substitute the units. For R unit is ohm. For A area meter square we have, and for length L we have meter. So now I am substituting here. For R ohm, for A meter square, for L meter. Meter square meter cancel. Then what do you get? Rho is equals to ohm meter. That's why here resistivity can be measured in terms of ohm meters. And children, here now you have to define the resistivity. What is the perfect definition for now rho? So for that here simply rho is equals to RA by L. Rho is equals to RA by L. So here when A is equals to 1 meter square and L is equals to 1 meter. In that formula A is equals to what? 1 meter. Let A is equals to 1 meter square and L is equals to 1 meter. Then what do you get? Rho is equals to R. Rho is equals to R. Here what is rho? What is rho? resistivity and what is our resistance of the conductor. Resistivity of conductor is nothing but equals to the resistance of the conductor when its area of cross section is 1 unit and its length is 1 unit. Clear? That's why here specific resistance or resistivity also called as specific resistance. Resistivity is nothing but it is the resistance of a conductor of unit area of cross section and unit length. That is the definition of resistivity. Very simple. We know formula rho is equals to RA by L, in that A is equals to 1 meter square and L is equals to 1 meter. Then what we write? Rho is equals to R. Very simple. Specific resistance or resistivity is equals to the resistance of a conductor of unit area of cross section and unit length. That is the definition of specific resistivity. And now we go for, so children, what you have to say? Specific resistivity is nothing but resistance of a conductor of unit length and unit area of cross section. And tell me now, specific resistivity depends on how many factors? 3 factors: length of the conductor and area of the conductor and resistance of the conductor. Okay children, now here already we learned completely about I gave information about the resistivity. Now here, what is conductivity? What is conductivity? So here conductivity is shown like sigma. Sigma is nothing but 1 by rho. What did you say? 1 by rho. Here sigma is equals to 1 by rho. What is sigma? Sigma is nothing but conductivity. What is that? Conductivity. Clear? That means sigma is equals to 1 by rho we are saying. What is the rho value? RA by L. That means what? Sigma is equals to L by RA. L by RA. Now units are what? Meter by ohm meter square. That means what? 1 by ohm meter. So this is the unit of conductivity. Got children? Very simple. What is mean by conductivity? Conductivity is nothing but reciprocal of resistivity. That means conductivity is generally shown by the sigma symbol. Sigma is equals to what, right? 1 by rho. Sigma is equals to 1 by rho. That means conductivity can be defined as reciprocal of resistivity. Sigma is equals to 1 by rho. Already up to now we discussed what is rho and what is its formula. Rho is equals to RA by L and we have substituted. Then sigma is equals to 1 by RA by L and sigma is equals to L by RA and units are ohm meter. So children, this is about the conductivity and resistivity. So we discussed now here what is resistivity and what is the relation between resistance and length and what is the relation between resistance and area of cross section and what is the conductivity and what is the relation between conductivity and resistivity. So children, I hope you understand. If you can understand this one, like, share and comment the video and subscribe my channel for to see all the videos. Okay, we will meet in the next video with some other interesting topic. Bye children, take care.